This is the 1998. Blocks A and B of mass 15 kilograms and 25 kilograms respectively are connected by a light inextensible string as shown in the diagram. The coefficients of friction are 0.4 for block A and 0.2 for block B. The blocks move down the plane which is inclined at 30 degrees to the horizontal. Find the acceleration of block B. So what we're going to start off with is our inclined plane, like so. Then what we're going to have after that is our two blocks, block A trailing block B, and they are connected together, like so. Now, once we have that done, what we're going to do is we're now going to try and figure out what's going on, A and B. Now, we have R1, the usual business of R1 and R2, being supporting it upwards. We're going to have 15G going directly downwards, and then we're also going to have 25G going directly downwards. Now, what we're next going to do is break it up into its components. Weight in both directions, okay? Now, as said before, if that's 30, makes this one 90 minus 30, which is 60, which in turn makes this one 30. So, it's going to be 15G cos 30. Anybody know what cos 30 is? Or 15 cos 30? Sorry? So, 15 cos 30, I'll just put it in the calculator. Oh, them in radians. Just make sure you're not in radians, but before you do this, lads. So 15 cos 30, 15 root 3 or 12.99. I might just I might be inclined to just go for decimals today. It's just a bit on the crazy side. I suppose we could just, okay, so we can just we'll put it down normally for the time being, like 15G sine 30, 15G cos 30, and we'll figure it out then. So that's going to be 25 cos 30 on the way down, and then this way it's going to be 25 sine 30, 25G sine 30, 25G cos 30. Alright, let's see what equations pop up, and then we can decide if we're going to put it into decimals or not. Now we're going to do block A. Block A on its own. Alright, now the one thing I was forgetting about was the fact that they're tethered together. So T is pulling block A down the hill, but it's pulling against block B's motion. So there's two different scenarios there going on. Okay, so then what we're going to do is block A, we're going to calculate what the friction value is. So friction, 1 second. So what we get here is friction, okay? And friction is going to be mu R1. Now what is R1, lads? R1 is in complete opposite direction to the weight. And the weight is 15G cos 30. So it's going to be 15G cos 30. Now, to get that, we're going to have to multiply it by 0.4, aren't we? To get the friction. So it's going to be friction. Friction is going to be 0.4 times 15G cos 30. So what's 0.4 times 15G cos 30? If you put it in the calculator, it's going to be 3 root 3G. Okay? So that's the friction. Now, we're going to do block A parallel to the plane. So, parallel to the plane, the force, which is going diagonal right down, and what did we say the acceleration will be? We call it acceleration A of the 15. Okay, so acceleration A. Now, they're both going to have why are they going to have a common acceleration, can you tell me? Well, block B encounters less resistance, So block B would be going faster on its own, but because it's tethered to block A, therefore they're going to have a common acceleration of A. So that's very important to know that the system's set up that particular way. Then what we're going to get is force, which is 15A, ends up to be tension plus weight minus friction. Okay, so it's going to be T plus 15G sine 30 minus root 3. So what happens next is it's going to be 15G sine 30 minus root 3 over 2G. Okay, so then I'm just going to turn it all into decimals here because I'm just going to turn this all into decimals. So it's going to be T, and I'm going to put all of this into the calculator and round it off to like 3 decimal places. And I'm going to leave G where it is though. I'm going to leave G exactly as is. So it's going to be 6.634 G. Okay. Now, what I'm going to do next is I've done block A. Now I'm going to try block B. Okay. So block B is going to be its friction is mu R2, which is going to be 0.2 is its coefficient of friction. Its R2 value is going to be 25G cos 30. The reason why it's 25G cos 30 is it's in the opposite direction. See, R2 is up against this component going down to 25G cos 30. Okay, so we're going to put all that in the calculator and we get 5 root 3 over 2G. Okay, now we're going to do block B parallel to the plane. So block B going along the plane. So force equals its weight minus its tension, because the tension is pulling it back up the plane, minus its friction, that's also working against it back up the plane. So it's going to be 25A equals W, which is 25G sine 30, then minus T minus 5 root 3 over 2G. Like last time, I'm probably going to try and combine them now. So easier. So what I'm going to do here is I'm going to actually take A plus B here. I'm actually not going to use the decimals after all. I'm going to copy and paste this down. This part here, that's equation A. This one here is equation B. Now, what I can get here, when I add them together, the tensions cancel, and I'm going to get 40A equals 40G sine 30. What's sine 30 by any? Can anybody tell me? Is that half? Okay, so sine 30 is a half, which is perfect. Minus 6 root 3 all over 2. 6 over 2 is 3, so it's going to be 3 root 3G. Okay, and then now once we're here, what we're now going to get is 40G sine 30. So A is going to equal 40 sine 30. 40 sine 30 minus 3 root 3, which is 14.8. And 14.8 multiplied by 9.8 for gravity. Multiply by 9.8 and then multiply by another 9.8. It's going to be 145 Then 145 divided by 40. I've gone wrong. Quick mistake there. The friction value for the 15a equation was not root 3 over 2. It was 3 root 3 g. So it's 3 root 3 g. 3 root 3 g. And we put that over 2. It would be 6 root 3 over 2g. Added together to get 11 root 3 over 2g. Okay, and then what we could do there is 40 sine 30. So 40 sine 30 gets me 20, and then 20 minus 11 times root 3 divided by 2 is that there, which is 10.47. Multiply that by 9.8 because it's times gravity. And then divide it by 40, and that will get me my 2.56, so A equals 2.566 ms to the minus 2. Okay.